Hey guys, it's too deep today.
So, this is what we're learning about. Trigonometry means study of right triangles. We need to review the Pythagorean Theorem. And then there's 3 trigonometric functions. Try to say that 10 times fast. See? It's hard. So, Pythagorean Theorem. A squared plus B squared equals C squared. You guys are so smart, you can always tell me that hypotenuse has to be C. That's always across from the right angle. The legs can be A or B, vice versa. It doesn't matter how you place the legs. Just one has to be A, one has to be B. We've already done one problem here. The missing side, what was it that we were supposed to find? We were supposed to find this. We decided to call it B, right?
Yes.
We called that side B, so we set up the theorem A squared plus B squared equals C squared. A squared was 3 squared, so that's 9. C squared was 5 squared, that's 25. We subtracted 9 from 25, got 16. B squared equals 16, so B equals 4. That's where we are. We're right in the middle of this problem.
C equals 13.
Maybe.
Yeah.
You got 13 as well?
Yeah.
You got 13?
We only got 1. They're catching back up on us. I didn't even need time to think about it. We thought we would go.
Well, what side is this that we're searching for? A, B, or C?
C.
This has to be C. So that means we could let this one be A. We could let that one be B. So we have 5 squared plus 12 squared equals C squared. 5 squared is 25. That's 144. That still equals C squared.
Which is 169.
Add these together to get 169. That equals C squared.
And then all you got is just square root, and then it's 13.
Square root both sides, and you get 13. Okay, just square root on your calculator. So C equals 13. Now, this example 2 is going to be significantly more challenging, you guys. Here we go. You're going to have to simplify some square roots. Because you guys are smart and you can handle it.
We're not smart.
Let's say that this is 14. That's 8. Ooh, that was not 8. That's 8. And I want you to find that side right there. The numbers aren't going to work out as nicely.
Oh well. Can you break them down? Like, can you simplify them? Like, if you like square root 108, you have extra powers.
What side are we searching for? A, B, or C?
B.
Well, let's rule out one. Are we solving for C? No. 14 is C. What are we going to call 8? A or B? Doesn't matter. We're going to call it A. So that means we're trying to find B. So we have 8 squared plus B squared is equal to 14 squared. 64 plus B squared is 196. B squared, if you subtract 64 on both sides, you get 132. And here's what I don't want you to do, even on your assignment. You don't estimate. You could type in 132 on your calculator, square root it, and it will give you a decimal. Okay? It's 11 point something. But that's not what we're going for. We have to simplify this. What number goes into 132 that has a square root? Does 4 go into it? Does 9 go into it? Does 16 go into it? That's what we're searching for. 4 times what?
30. You could do 2 and you get 66.
So this is what you guys are going to have to do on your assignment, so you better pay attention. 132 is the same as 4 times
33. Now, why are we using the number 4 specifically?
Because it comes out as a 2. It's a perfect square. 4 is a perfect square.
So the 4 moves to the front as a 2, so b is equal to 2 square root
Of 33.
of 33. This is how I expect you to represent the answer. 2 times the square root of 33.
Yep.
Okay, here's one that's even more challenging. Buckle up.
It's a good thing we're sitting down.
Okay. This side is 20. This side is 2 square roots of 5. And we better do this one together so you don't get into the habit of making some mistakes. We're still using the quadratic form, or not the quadratic formula, the Pythagorean theorem. A squared plus b squared equals c squared. We just have a funky number in there to deal with, 2 square roots of 5. We have to figure out how exactly to square that. Now, 20, that's c, isn't it?
Yes.
What are we going to call 2 root 5?
A.
We call that a. Zuna. So we're searching for b. Now watch carefully how I write this. I want you guys to write it the exact same way so you don't get into some bad habits. What is a squared? It's parenthesis 2 square roots of 5 to the second power. Put it in parentheses. We don't know what b is. We're going to leave that as b squared. C squared is 20 squared. Now, a lot of students have some misconceptions on how to multiply or how to do that. What are your guys' thoughts?
Plug it into the calculator.
You actually could. Wouldn't be a bad idea to plug it into a calculator.
That's fine.
What were you going to say? It is true. That's part of it. That is part of it. This square does cancel out that square root. But before you can do that, this exponent has to go to both terms. What's 2 squared? And then if the square cancels with the square root, what are you left with? 4 times 5 is 20. So that whole entire term turns into 20. The exponent went to both numbers. It went to the 2. Listen. If everybody's talking, it's hard to listen. Okay? We did. The exponent went to the 2 and the exponent went to the 5. When it went to the 5, the exponent canceled out. But when the 2 went to the 2, that became 2 squared, which is 4. 4 times 5 is 20. And if you're still having trouble with that, you guys all have calculator, or you should by now have a calculator. Okay? It's really easy to type into a calculator. If you put in parentheses 2 times the square root of 5, and then you raise that to the second power, that's not what it is.
It's going to put 2 parentheses at the end.
Let me try it. 2 square root of 5. Close the parentheses. There we go. Then square it. Calculator tells you it's 20. So anyway, let's finish this up. 20 plus b squared is equal to 400. Close. B squared is equal to 380. So I don't want the decimal of it. We need to figure out if there's a number that goes into 380. So just start taking 380 and divide it by perfect squares. Divide it by 4. That one divides evenly, so let's use it. It is the highest one because 95 doesn't have any factors. That's perfect square. But you are right, we do want to find the highest one. So we're going to change, instead of 380, we're going to use 4 times 95. What does that change into? 2 times the square root of 95. So b equals 2 times the square root.
The higher you check it, it's the number. If that one can be divided by square.
Then that means it's a higher one. Yeah. 2 times the square root of 95. This isn't actually the main point of the lesson. This is all just preparation for the main topic of the lesson. But you are going to be doing a lot of this, a lot of Pythagorean theorem. Okay? Here's the main point of the lesson. Now we got to start talking about trigonometry. Trigonometry has a lot to do with right triangles. Just curious, and it's okay if you don't know this, but have any of you heard of sine, cosine, or tangent? Sine, cosine, you've heard of them? You've heard of them? Sine, cosine, or tangent? That's trigonometry, sine, cosine, and tangent. Okay. Draw a right triangle. I make it kind of large because we have to put some stuff inside of it. I've practiced years and years to become so. Now I want you to put this symbol right here. It's just a circle with a line through it. It's a letter in the Greek alphabet. It's called theta. What's that? It's a circle kind of with a line through it. Theta. All that means, theta is a variable for an unknown angle. We don't know what the measure of the angle is. Since we don't know it, we call it theta. Theta is just a variable like x and y, but instead of using x and y, they use Greek letters. Theta, sometimes they use alpha and beta. Nope.
You know what I really looks like? It's one of those blue things in science. It's like color.
Okay, listen. This is still called the hypotenuse. That has not changed. The hypotenuse is always across from the right angle. But we no longer call these two sides that form the right angle. We don't call them legs anymore. Okay? There's two options. One of them is called the opposite side. One of them is called the adjacent side. And it has to do with where this missing angle theta is. Okay? So listen carefully. If this is where theta is, how would you classify this side? The opposite side or the adjacent side? Adjacent means next to. Okay? Opposite means across from. So in relation to this angle theta, how would you classify this side? Opposite. This is the opposite side right here. Adjacent means next to. Well, let's do opposite first. That's the opposite.
Adjacent,
A-D-J-A-C-E-N-T. Adjacent, it means next to. The adjacent side comes together with the hypotenuse there to form that theta. But this is only the opposite side because this is where theta is. You guys have to understand this. I don't want you to erase anything because it's going to get messy in your notes, but if I put theta up here in this corner, is this the opposite side anymore? That would be the adjacent side. And what would this side be here? This would now be the opposites. The opposite and adjacent are always going to be switching depending on where theta is. But what's never ever going to change?
The hypotenuse. Hypotenuse will always be the longest side.
Okay. It's always across from the right angle. How are we doing so far?
I'm doing all right. Thank you.
There we go. Isn't that how we started?
Yep.
Okay. Now, there are three trig functions called sine, cosine, and tangent. Sine, cosine, and tangent are functions. We haven't talked about functions in a while, but it's important that you understand that they are functions. That means they take an input and they produce an output. A function is a machine that takes a number and produces a different number. Like a square root is a function. If you plug something into a square root, what happens? You get something else out. Or squaring something is a function. If I put 4 inside of a squaring function, you square it and get 16. Those are all functions. Sine, cosine, and tangent are functions. Okay? That means you put in an input, you get an output. Now, they abbreviate these, so you don't have to write out the whole word. They just do S-I-N. You read that sine. The input is the angle measure. We don't know what the angle measure is, so we just call it theta. And it's the same for cosine. The only thing that you input into sine, cosine, and tangent are angle measures. We know what the input is. We place the angle measure inside the sine or the cosine or the tangent function. What's the output? Okay. Now let's just review something that you know real quick. Let me get a blank screen over here. Let's say that this is the function. And I place that number inside of it. What comes out of that? Which one's the input? Which one's the output? This is the input. That's the output. Okay? So, how did we get 3, by the way? How did we know that the square root of 9 is equal to 3? How do we know that? Because 3 times 3 equals 9. We know how to find the output for square roots. We know how to find the output for most functions. Okay? How do we find the output for sine? It has to do with the triangle. Okay? The right triangle. You take a look at where the angle is. The output for this function is the fraction, where the numerator is the length of the opposite side, and the denominator is the length of the hypotenuse. So if I ask you for the sine of an angle, you have to look at the triangle and look at the opposite side and divide it by the hypotenuse. That's what the sine of that angle is. Cosine is similar. It's still a fraction. It's the adjacent side divided by the length of the hypotenuse. The tangent is the opposite divided by the adjacent. That's the way it's been defined. These are all just man-made definitions. The sine has been defined this way. Now you're going to have to remember all of this. To make it easier, there is a goofy little acronym that you might have heard and had no idea what they were talking about. So I want you to write this down in big capital letters. So, with SOH, and then Ka with CAH, and then Toa with TOA. SOHCAHTOA. You can remember SOHCAHTOA, right? Say it. SOHCAHTOA. It's an acronym. Acronym means the letters stand for words. The S, what do you think the S here stands for? The sine. O stands for the opposite over hypotenuse. The sine function is opposite over hypotenuse. The C stands for cosine. The A is the adjacent over hypotenuse. Cosine is adjacent over hypotenuse. The T stands, you guys get the picture, right? T stands for tangent, O is opposite, A is adjacent. You're going to have to remember the definition of these trig functions on the test.
You're going back to the question where
well, on the homework I say, what's the definition of sine? And you have to tell me it's opposite over hypotenuse. But for the most part, this is what your question is going to be like. Here's example 3. So, tell me what the sine of theta is.
First, you have to remember the definition of sine. What's the definition of sine? It's opposite over hypotenuse. So now you just got to figure out what the opposite length is and what the hypotenuse length is.
If you didn't fraction, can you just simplify it?
Simplify the fraction, but leave it as a fraction. Don't put it as a decimal. So here's where the angle theta is. What's opposite from it? 8. And what's the hypotenuse? 10. So it's not that these problems are really hard to do. You just have to remember what the sine is, what the cosine is, what the tangent is. So the sine is 8 over 10, which simplifies to 4/5, and you just leave it. That's the answer for the sine. The sine of theta is 4/5. Okay? What about the cosine of theta? What's the definition of cosine? Adjacent over hypotenuse. We know the hypotenuse is 10. That hasn't changed. Adjacent means next to. Which side is right next to the angle? 6. So it's 6 over 10. And that's 3/5. Tangent of theta. Remember TOA, SOCA TOA, T-O-A. Opposite over adjacent. Opposite over adjacent. What's the opposite length? 8 over 6.
Divided by 2 is 4.
So it's 4 over 3. Okay. Now here's what this has. Did we have to use Pythagorean Theorem for that problem? We didn't, did we? Because we already knew all 3 sides. Yeah, so you're gonna have a couple of problems like this where it's already set up for you. But for the most part, this is gonna be the problem you're gonna have to face.
So we have to solve one and then. So it would be 81 plus 90. Okay.
So do we have all the information we need just to fill this in?
No, we don't. We're missing the square root.
We're missing
The square root.
we're missing one of the sides. Which side are we missing, by the way? The opposite, the adjacent, or the hypotenuse? We're missing this adjacent side.
Oh, I thought you meant like, sorry.
We're missing adjacent. We have to use Pythagorean Theorem first to solve for this adjacent side, and then we could fill in the trig ratios over here. So, the side that we're missing, what should we call it? A, B, or C? B? All right. So we have 3 squared
So it would be 81 minus 9.
plus B squared is equal to 9 squared. 9 plus B squared is 81. B squared equals 81 minus 9, 72. Now we got to be really careful. Yeah, B is equal to the square root of 72.
And 72 is.
But 72 is 36 times 2.
So it'd be 6 and 2.
So the 36 moves to the front as a 6. So it's 6 square roots of 2.
And then you're going to...
So let's fill in the ratios now. The definition of sine is opposite over hypotenuse.
And then cos is...
So that's going to be the opposite length. What'd you say, Dallin? The opposite length is 3, the hypotenuse is 9. Good. 3 over 9 simplifies to 1/3. The cosine, be careful here, the cosine
adjacent and the hypotenuse.
is adjacent over hypotenuse.
So
6 square roots of 2 over 9. We have to be careful on how we simplify this. Forget about the square root of 2. What if it were just 6 over 9?
3,
It'd be 2 over 3, so this simplifies into 2 square roots of 2 over 3. Nope, just leave it. Now this one's going to be, this is opposite over adjacent. This is 3 over 6 square roots of 2. So it's 1 over 2 square roots of 2. And I actually would have to dock maybe a half a point if you left it like this. What's the problem here? Which 2? The square root. We can't have a square root on the bottom of a fraction. We can't just move it to the top. That would be nice. That would be awesome if we could just move it to the top. What do we do with it? We can't square it. We can only square something if we're solving an equation. We're not solving an equation. Just take half the points? No. We better go over this. Let's do a different problem. What if it was just 3 over the square root of 5? I know you guys have learned this before.
You just type it on the calculator?
You multiply it by the square root of 5 over the square root of 5. Why does this work? Well, first of all, what's the square root of 5 times the square root of 5? It's the square root of 25. But what is the square root of 25? So now there's no more square root on the bottom. That's why this works. What's... Well, no,
and then just do square root to the top.
So it's 3 square roots of 5 over 5.
I mean, instead of doing square root to the top, can't you just make the bottom 5 and then the top 1 2?
Not all the time, no. So what are we going to do here? What are we going to multiply it by? Square root of 2 over square root of 2. So in the numerator, we're going to get square root of 2. Well, 1 times the square root of 2 is just square root of 2. Now be real careful here. What is this? Square root of 2 times the square root of 2?
4.
And what is the square root of 4? 2, but then we have to multiply it by this 2.
Oh, I can see why it doesn't work.
So it's square root of 2 all over 4. It's the square root of 2 all over 4. What's that? We can't simplify it any further because we can't mess with this 2 once it's underneath the square root. Yeah. Once the number's underneath the square root, you really can't do anything with it. If you're simplifying fractions, you have to leave this alone. We better do another one of these real quick before the bell rings. Part C. Yeah, we're almost out of here.
Okay. So we're just going to follow the
Yeah, you're going to have some of them.
I have no use for this now.
It's empty. I already used it all.
There's still plenty of time. We have 10 minutes. Same direction. Sine, cosine, and tangent. Sine, cosine, and tangent.
The sine would be opposite over.
Yeah, one of these functions we can do right off the bat without having to find this missing side. Which one do we already know? Why do we know sine?
We know the opposite, and we know the hypotenuse.
Yeah, this is the opposite. This is hypotenuse. So without solving for that missing side, we can at least do the sine. It's 2 squared to 3 over 11. But in order to do cosine and tangent, we need to find that other side. We're going to call it b. So we have a squared plus b squared equals c squared.
So it's going to be 4 times 3, which is going to be 12. And then 11 times 11 is going to be
We know 11 times 11, yeah, that's 121.
21. And then that one's 12.
Yeah, and for some reason, students have trouble with this term right here. The exponent has to go to both terms. 2 squared is 4, and then the square root of 3 and the exponent of 2, those just cancel each other out, so you get 4 times 3, which is 12. So that's 12 plus b squared equals 121. Subtract 12 on both sides. (121 minus 12). Come on, people, wake up. 109. So b is equal to the square root. Now we've got to figure out if there's a number that goes into 109 that has a square root. Get your calculator out, take 109, and just start dividing it by perfect squares.
Divide by 4.
It doesn't divide by 4. What else should we try?
16.
We're forgetting 9. Doesn't divide by 9.
Intelligent, 16.
Divided by 16. That doesn't work. What else should we try?
25
25 doesn't work.
81. 2.
36 doesn't work.
Try 81. 81.
49.
81, man.
49 doesn't work.
81.
64 is too big. 81's too big. Doesn't have anything, so we can just leave it as square root of 109.
Well then, that was big.
So now we know the adjacent side. What's the cosine now that we know the adjacent side?
It's the opposite adjacent and the hypotenuse.
You guys are starting to lose focus. Come on, you guys.
If the adjacent and the hypotenuse would be the square root of 109 and 11. And that would be the answer.
Okay.
And then the last one would be opposite versus adjacent. So the opposite is 2 over 3 and then the adjacent is 109.
You guys are going to have to pay real good attention to this last one, the tangent.
So it'd be 2, the square root of 3, and then the square root of 109. Now, I'll take the square root and then multiply. So then it would be 109.
Hold on. Colton, what would you do next? For this one. How? Were you paying attention to the last problem? We had a square root of 2 that we had to get rid of, so we multiplied it by square root of 2 over square root of 2. What is it we're trying to get rid of over here? So how do we do that? Has to be the same thing. Square root of 109 over the square root of 109. Okay. Amazing. What happens when you have a square root of 109 multiplied with itself, square root of 109? Okay, we get 109. What about here?
Would the squares cancel themselves out?
Only if it's the same number underneath.
Would you multiply the square root?
You have to multiply the numbers underneath. So it's 2 times whatever 3 times 109 is.
So 3 times 9 is 27. So would be 327.
There you go. That's the tangent. So there's the sine, there's the cosine, there's the tangent. This is the very, very beginning of trigonometry. We're going to go a lot more in detail this unit.